Hey, good afternoon. Salaam alaikum. So excretory system we are discussing, right? So actually I have completely discussed the process. We have to fill up the tube, right? From here, the urine formation. Please take it. Page number B in excretory system. Excretory page number 3. Urine formation in kidney follows three main processes. What are they? Can you remember? Ultrafiltration. Yeah. Ultrafiltration, selective reabsorption, secretion. Can you write that? Ultrafiltration, selective reabsorption, and secretion. Ultrafiltration, selective reabsorption, secretion. So hope you remember. When the arterial is entering the Bowman's capsule, here it makes the glomerular network and goes out. What is this tubule? Efferent arterial, and it goes out is efferent arterial. What are the two arterials here? Efferent arterial and efferent arterial. And it makes a glomerular network inside, that is the glomerulus. Glomerulus. Okay. So we take that separately here. You see, it is a network of capillaries, okay? But I'm taking only a part. Just to refer, we have already discussed. So once again, I'm reminding you what happens here. The blood which flows along the efferent arterial, when it enters the Bowman's capsule, the cavity, the inner part, right? So here it makes the blood capillary network, which we term as the glomerular network. So this area is what we name as the glomerulus, okay, or as glomerular network. So now the efferent arterial and efferent arterial you take, efferent is more in diameter than efferent. Efferent has a less diameter tube. So since the diameter is less here, the volume is less, right? Volume is less. Tube is small. Tube is small. It is something like the pen and the marker. For example, this is efferent, efferent, right? So volume is less here. As the volume is less, pressure would be high. Pressure would be high. So the blood tries to go here and there, and the only way out is within this network, which are even small. This is given in the same thickness, just a diagram. But the capillary networks are even tiny, even smaller in size, in the thickness. So passing that, okay, crossing the wall of the blood capillary and the inner wall of the Bowman's capsule. Can you see? It is the inner wall, right? The inner wall of the Bowman capsule and the wall of blood capillary. Blood gets filtered. Blood gets filtered. Correct? Where is it filtering into? From the blood into Bowman's capsule cavity. So this filtration process is what we term as ultrafiltration. So blood getting filtered into Bowman's capsule cavity from the blood capillary or the glomerulus, passing two walls. What are the two walls? One is the wall of blood capillary and the other one is the inner wall of Bowman's capsule. Inner wall of Bowman's capsule. You understand that? So again, blood gets filtered from glomerular network into the cavity of Bowman's capsule. Glomerular network into the cavity of Bowman's capsule. It's transferring. Okay. So this happens due to the high pressure inside the efferent arterial. And this happens passing two layers. What are the two layers? One is the wall of the capillary network and then the inner wall of Bowman's capsule. So this process is what we name as ultrafiltration. What filtration it is? Ultrafiltration. Did you understand that? Okay, shall we write there? The process of the process of blood get filtered. The process of blood gets filtered through the wall of glomerulus, through the wall of glomerulus, through the wall of glomerulus, and the inner wall of the Bowman's capsule, through the wall of glomerulus, and the inner wall of the Bowman's capsule, and collected into the cavity of Bowman's capsule, and collected into the cavity of Bowman's capsule, and collected into the cavity of Bowman's capsule due to the high pressure, due to the high pressure inside the efferent arteriole. Inside the efferent arteriole is known as ultrafiltration. Is known as ultrafiltration. It's known as ultrafiltration. Okay, right. Now, the glomerular filtrate is there. Now, what gets filtered here is the blood. After getting filtered, what goes down the Bowman's capsule? That is what we term as the glomerular filtrate, right? This glomerular filtrate mainly contains water, glucose, amino acids, vitamins, medicines, ions, urea, hormones. These are what it contains. And strictly, it does not contain blood cells. No red blood cells, no plasma proteins. No red blood cells, no plasma protein. Remember, within the glomerular filtrate, there is no red blood cells, no plasma proteins. Some of the proteins are not present. Okay. If it is present, you have a problem in this filtration. That's the idea. It is a disease condition. Clear? Okay. So glucose is present. Glucose is present, but will be reabsorbed. Will be reabsorbed in the second state. Selective reabsorption. That is a state where glucose would be 100% taken back. But if it is in urine, if it's present, then it is also a problem. That happens in high diabetic condition, high sugar level. Okay. So accordingly, all these things are organized well in order to regulate and maintain a good healthy system. Okay. So this is about the glomerular filtrate. So go to the next point on your tube. Ashwat. Last two calls, you see the same thing. Please take the note. Glomerular filtrate contains. What do they contain? Green and white. Water, minerals, amino acids, glucose, vitamins. Right there. Right. So hope you can remember this glomerular filtrate. It is about 120 cubic centimeters for every minute average. 120 cubic centimeters means 120 ml, right? 120 ml. So 120 ml for every minute means for 10 minutes, how much would be? 1200 ml, which is almost 1.2 liters. So that's what I told you. Every 10 minutes, you have to be in the washroom there. Okay? Right? 1.2 liters of urine getting filtered. So, what is the mechanism you do have? No, it is not the only problem, right? Why? Every 10 minutes you have to stay in the washroom and every 10 minutes you have to refill yourself. Why? 1.2 liters of water goes out, right? Imagine. So, we are getting dehydrated, right? So, that is why I told you, we are a marvelous creation, right? Okay, we have nothing errors. But the thing is, we make the errors within ourselves. Why? This is not control. All the problems are because of this, right? All the biological problems and the physical problems are also because of this, right? No control in words. Just start running out. So, it becomes a reaction. Okay? So, you see, this is maintained. How it is maintained? In the selective reabsorption process, almost 90% of this is taken back. So, there is no problem in urination and there is no problem in dehydration also. Both balanced. Both balanced. So, this is a mechanism too. And glucose, 100% taken back in healthy people. So, glomerular filtrate contains glucose, right? But it will be reabsorbed 100% in selective reabsorption process. So the urine does not contain glucose. If it contains glucose, randomly if it happens, fine. Once in a while it happens, maybe because of a high diet. Suddenly when you are going for a party or an event or something else. No control over there, everything you eat. Once, twice, thrice, you eat. So sweet, all the sweets, all in high glucose level, you are consuming. So at that time, sometimes it might be there. Because high glucose content. Right? Randomly if it happens, fine. But every time you do have that, always the urine contains glucose, means you have a problem here. Then you have to consult. Okay. So anyhow, these are some mechanisms to control, to regulate this formation. That is what given over there, below that. And the selective absorption process is what given here. You see, the Bowman's capsule given. This is the Bowman's capsule, and which goes down here. It is the arterial. So you can see here, the efferent arterial comes in, it makes a network and goes out as efferent. First ultrafiltration we discussed. And you can see this goes around. Actually, it makes a network. It makes a network. You can see in the previous diagram of the nephron. On your tube, in the previous nephron diagram, you can see like a network, your blue guy is connected like a noodle. Okay? But here only one part we take to learn what happens here. So you see, right? Now this is the area where the blood goes, right? Can you see? This is the area where the blood goes. Okay? That is the area where the blood goes. The surrounding part here, who is this? It is the nephron, correct? Can you see that? Right. Right? It is a nephron. So see what happens. After passing down this glomerular filtrate, when it comes down, so the black color is the nephron. From nephron to blood, selected particles are taken. Correct? From nephron, black color is the nephron. From nephron to blood, selected particles are taken. What are the selected ones? 100% glucose, almost 90% water, minerals, urea, some amount, amino acids, vitamins are taken. This is what we term as selective reabsorption. Selective reabsorption. Okay. That is the second stage. And what is the third stage? Now this happened from nephron to blood, right? We did that also. Nephron to blood. That is the selective reabsorption. What is the third stage? In return, nephron gets something from blood. Now earlier nephron gave something to blood, right? So it has to take something from blood. So blood gives out some ions like hydrogen plus ions, potassium plus ions, hydrox, some sort of ions, ammonium ions, creatinine, vitamin D. So these things will be given back by blood to the nephron. So that happens as a third stage where it will be given back from blood to the nephron. Blood to the nephron. That is the third stage you term as secretion or secretion. Is that clear? Okay. So accordingly, three stages. What are the three stages? Ultrafiltration, selective reabsorption, and secretion. So let's try there. Selective reabsorption. The process of the process of absorption of absorption of most of the constituents again into blood capillaries again into blood capillaries associated with nephron when glomerular filtrate moves along the nephron when glomerular filtrate moves along the nephron is known as selective reabsorption. Yes. What's up? Why is this piece there? It's going around like a tube. No, if it goes straight, you know what happened? We need more surface area. Can you remember the small intestine? 6-7 meters long. What if it is long like that? Our body height should be like that. Correct? Test is same thing. And this as a large diagram we learned. This is very small, right? Why? Kidney itself, when you take it, is less than 15 centimeters, isn't it? When you take the ruler, somewhere like this, 15 centimeters. Okay. About 11 or 12 centimeters only the length of kidney. Kidney, okay, kidney, not this kidney. Within the kidney, millions of nephrons are there. Then how much small it should be? Right? So being smaller does a big work. If this is not there, we can't survive. You can see, no? Kidney people, the kidney issue. Kidney failed people, they can't survive. They lead towards the death. They are counting the days. Right? So those diseases also we have discussed today. Fine. Are you done? Yeah. So accordingly, this is what we discussed about that 1.2 liters of urine. Secretion. What is secretion? The process of release of some of the substances from whom? Blood to nephron. Blood to nephron bed. Okay. And forms up into urine. That is called secretion. Now, what is formed at last is urine. And what are the substances released? Hydrogen plus ions, potassium plus ions, ammonium plus ions, creatinine, medicines also, and vitamin B. Vitamin B. Those parts are given on your tube. Okay. Fine. Removal of urine. Now, so-called urine collected will be transmitted into the kidney. Can you remember? Kidney transmitted to the kidney and the renal pelvis. Can you remember the parts? It was taken like this, right? Okay. From the pyramids, renal pyramids are what containing the nephrons. From the nephrons, all the urine collected will be transmitted into the renal pelvis. From the renal pelvis, it is transferring into urinary bladder. Okay. So via the ureters, it is transferred into urinary bladder. Bladder fills up and will be removed from the bladder via the urethra. So this is how it happens. And this urine collected mainly contains what? About 96%. And about 2%, it's not 0.2, actually 2% of salt, 2% of urea. And trace amounts, small amount of uric acid and creatinine also will be present. If these amounts are changing, like the urea, uric acid, creatinine, if they are changing, increasing by amount, maybe there's a problem. So that is how by the blood test, urine test and all, we are getting some ideas to diagnose the issues because of the contents, looking at the contents. Contents are changing, means there's a problem. That's also not random. Every time, always. Randomly it may happen. Okay, because of the dieting, a sudden change in your diet, it might happen. But continuously, if it happens the same thing, then definitely you are having a problem where you have to treat with. At the initial stage, if you are treating, you're fine. Otherwise, it becomes a worse. Okay, fine. So accordingly, what are the diseases? What are the diseases? So you see, renal failure. What is the first one? Renal failure. What is renal failure? The word renal refers to kidney. The word renal refers to kidneys. Look here. Now, if the kidneys are failing, what cannot be done? Urine filtration, the blood filtration cannot be done to form up urine. Form up urine. It is something like the machine is not working, output will not be fine. Okay. So what happens here? You see, the weakening of urine filtration. Weakening of urine filtration process in nephrons. Nephrons mean they are the tiny parts, right? The structural units of kidneys. So urine filtration process in nephrons become malfunction or it's not working. It's not happening. It's weakened. This is called renal failure. Please underline. Infections by microorganisms, heavy metals, mercury, arsenic, various medicines, and carbon tetrachloride may cause. Now, what are the reasons for this renal failure? Reasons are heavy metals, mercury, arsenic, and heavy metals. Are you eating heavy metals? No. Do you eat heavy metals? Then how does it heavy metals are drinking? Well, yeah, heavy metals are basically these metals are heavy metals means high density. Density is high, relative molecular mass is very high. Okay, set of heavy metals are there. Arsenic, cadmium, zinc, okay, different metals are there, mercury. So these heavy metals are present in the soil, present in the earth's crust, right? Now, and also by the companies, the factories, those who are using it, they release out, they dispose out the garbage, right? The electronic devices, basically, mercury barometers, mercury lamps. So different sort of those ingredient containing equipment, devices, they are disposed. Where are they disposed? Into the environment. Okay. The products gases are being released. So we are exposed to it. And also the food. Food might be pure. It's good, it's hygienic, but the wrapping you take might be containing you know, might be. I'm saying. So in that case, what happens? There is the problems. Sometimes in the food, these contents might be very small in the home. It's not good. Getting the Oh, basically, this was there within the farm. At the initial stage in our country, it was one of the farm actually got this problem because it was limited to the housing areas, right? That is the place where the soil is there, right? So whatever is inside, they are becoming exposed to. So you are getting exposed to. But now you don't want to go to the harvesting area. It comes towards your place with food. Okay. And also the environmental pollution. So we are exposed. Now even the babies, the small kids, they do have these kidney issues. The junk food is a major problem. Instant food. Okay. And so called energy drinks and alcohol, smoking, right? So some sort of drugs being added with. So all these are issues. Right? So you see, accordingly, these ones when it is added, something like carbon tetrachloride, okay, and microorganisms is also good. They cause the renal failure. Renal failure. And pH of blood decreases due to accumulation of urea. Urea, uric acid, when you are taking, I told you if it is increasing, urea, uric acid, that's an acidic medium. So acidic medium, the urine becomes. pH is reducing means it goes towards acidic. Goes towards acidic. So that also a change. And by taking immediate treatment and a healthy lifestyle, one can maintain a healthy kidney. If treatments are not taken, even after the diagnosing, maybe within 8 to 14 days, within 2 weeks' time, it may be leading towards into the next level of worse condition. So it may be continued with acute renal failure. Acute renal failure, or we say AKD, acute kidney disease. Okay. So then blood is filtered by a machine called dialysis. So here we need dialysis. You should have heard of this word dialysis. But what's happening here? What's happening in dialysis? You can see the people those are having renal failure. The filtration is not happening. No, these things you must know. Not only theoretically, but even practical life also you must know. So when you are looking at a person, then you know this is what actually happened. Okay. So if the renal failure is there in a person, the renal part, the kidney is not working. Okay. So the filtration cannot be done. What happens? Now this water, anyhow, you are taking water. So this water will be getting collected between the cells. It's not getting filtered in the urine, right? In the kidneys, right? It should come out along the arterial path, and it is getting filtered. It is getting added, actually, getting added, not filtered, added within the living cells. We term it as the intercellular spaces between the cells. So now it adds more water between the cells. Means what happened? The tissues, the organs, and all seems to be inflated, swollen. That is why those people, the legs and all will be swollen, swelling up. It gets swollen. You have seen, right? They can't walk. Why? The legs are swollen. They have to keep the legs up, and alone they can't move the leg down because it's heavier. Why heavier? Water collects. And this water does not contain only water, toxic components are there like urea, uric acid, those things are there. And now, whatever the toxic component should be removed from the body is still stored in our body. Means, is it a good health condition? No, toxic. So they get allergy conditions and dry skin. Okay, it would be wounded. And basically, since they are having diabetes, the diabetes patient will be having these kidney issues as well. So those wounds will not be easier cured. It is a big problem now. So one after the other. Okay. So you see, accordingly, immediately once you get into once you diagnose this problem, immediately you have to go for treatment. If you just ignore, it may take your life away. It happens. Okay. So you see, dialysis should be happen in order to take that water out. There are measures that we are working out with where the water collected will be removed. Sometimes 4, 5, 6 liters of water will be taken out and along with that, so that we have to replace the blood. Okay, so that's not small, easy rule. The people those who are getting that get the pain because the blood is taken, the water is taken off using machines. Okay, so they will be having the pain for 1 or 2 days. Right? So some people would be having that issue for once in a week, twice in a week, sometimes every week you have to do until they are alive. Oh, you have to go for a renal transplant. Kidney should be transplanted. But for that, a donor should come. Either in 2 ways. One, in financial aspect. Right? He might or she might need money. So they are selling their kidneys. They are selling the kidney. Kidney is sold. So it is given to the other person. But you can't be just like in the movies, cutting off there, just taking one or not like that. There are a lot of things, formalities. Okay, formalities should be fulfilled. Right? So they are showing that here they are cutting the kidney. Here you don't have the kidney. Kidney is there here. Now you see some movies that they are showing up. There is a bullshit actually. You say nothing. Just they are showing, but we are also not. Kidney is not there. Okay? So kidney you have it, and you can't just cutting it off. Several things will go. First thing, the blood should be matching up. Otherwise, the donor just go. Recipient would be dying because of transplant. Why? Blood is not matching. Okay, that should be matching up. And the donor's condition should be also considered, examined. Why? He should be alive after that, right? He should not be weak. He should be strong, right? So you see, all those things should be considered. Anyone else? And the other, maybe because of the relationship. Father, mother, son, daughter, like this, the relationship they are transferred. They are giving in their own, willingly, voluntarily they are giving. The person who gets the kidney might be living for someone. The person who gives might be dead. Okay? Oh, anything may happen. We can't assure. We can't assure. Because it's something like this. Now people say, can we live with 1 kidney? Yes, we can. But it is something like this. 2 machines you have to do work. 2 washing machines you got to do. Every day you are filling up with clothes. A lot of clothes you are giving out. Because you definitely need 2. Okay. Now you are going to keep off 1. And the entire set 2 in 1 you are going to give it in 1 machine. Whatever. It works a lot, right? It works a lot. Loads of work you are giving. Quickly it gets expired. It gets damaged, right? That is what. So this renal failure people would be given some data in this and they can't eat everything, they can't really eat everything. In fact, water. 4 to 5 liters of water are drinking. They are limited with starting 1 liter or 750 ml, 500 ml per day. Why? If you are giving more water, you have to filter it. Filtering is not done. If you keep filling up, legs would be swollen. Why? It is not getting filtered, being released along with. So it will be getting over there between the cells. So that it's linked. So we have to be grateful for all what we have got. Okay, that's why I told you we are a marvelous stage with everything. But there is one more story like this. Now, science is getting advanced. Right? Medicine is also getting advanced. I told you, don't just limit up with what you learn here. Okay, I already told you. Don't just limit up with what you learn here. What you learn today is 10 years back old syllabus. Okay, what you are learning in science is almost 10 years, 9 to 10 years old syllabus. Right? Plus, within that 9 to 10 years old syllabus, also 100 years back history is what we are learning. We don't learn the modern science, okay? What to do? I have to teach the same thing, right? Because that is syllabus. That is what you are going to write for the exams. Modern science is totally different. Okay? You go out of the world, you check out with the modern science, you have nothing in your mind, like, because you are blank. You don't have anything. You will be thinking, what the hell we were learning in science? Because nothing we learn. Nothing we learn with the modern world. Okay? We are still speaking about these things nowadays. Transplanting being successful. Machineries are also being invented now to transplant. Okay? After successful stories, they are researching and they go with. Okay? So a lot of things are happening. A lot of things are happening by a button press. Big changes we do. So it keeps advancing. So what I say is, don't just limit up with this. Okay? So why science become bored? Because of this. Why? Old stories are what you are learning to. That's not my fault. I have to teach that. Why? That is what you are going to write for the exams. Okay? So you have to get advanced, at least read some articles about the modern world, modern science. It's totally different. It goes up with smart working. Okay? Smart thinking. It's totally different. Science and technology runs the world. Okay? So these things you have to learn about your life. And you have to connect it with the modern world. Got it? Is that clear? So accordingly, a lot of things are being done now in order to reduce the death rate. But whatever we have been given a certain range of life, we will die one day. But as an effort, we are doing something. That effort becomes successful or not, that's a different story. We give an effort. Those efforts are what being advanced to do. So you see, for the renal failures also there are things that could be done. But the thing is, at the initial stage, you have to consult the correct doctor. Correct doctor means somewhere in a clinic, you are going for the doctor. No, clinic doctors are there, dispensary doctors are there. You are going for him and getting the consultation every day. It won't work out because they are general doctors, general practitioners. You have to go for a consultant who is a specialist in this kidneys. Clear? So, properly you have to get the meditation and you have to continue. So, at the first stage, we can recover because our body has that system. So, technologies are there, we have to use them properly. So, this is about the renal failure, and during this, there are symptoms. What are the symptoms? Excess urination will be there, and frequent urination during night time. At night, frequently urination happens, and painful urination, blood in urine, okay, proteins in urine, and urine discoloration, the color changes. It seems to be like red color. That's also because of this. Why? Red color, if it is converted, usually urine is not red color, pale to yellow color, pale to dark yellow. So if it becomes turned into red, that happens usually during the cold, common cold, the fever, and all it happens. Every day if it happens, somewhere there's a problem in the kidneys, we have to understand. We should not ignore them. Okay, so we should not ignore them. We have to speak to the related authorities. Otherwise, it becomes too late. So that is one about the renal failure, and the other one, nephritis. Nephritis means the kidney is getting swollen. Kidney is getting swollen. Swelling of kidney occurs due to infections and toxins, maybe because of the poisons. Also, infections causes this problem. Now you see, infections in ureters and other changes that occur in the body are reasons for nephritis. Other changes, the medicines are also affecting. Okay, infections. So during nephritis, it affects the glomerulus and also uniferous tubules. The glomerulus inside the Bowman capsule would be also affected. Uniferous tubules would be also affected. So the flow will not be continuous. Okay, it will be having a facing a block, right? So due to damages occurring in glomerulus, the volume of blood flow through it reduces. So the amount of urine formed also reduces. Therefore, the waste materials remaining within the body become high. Now I told you, right, there would be a block for the flow. So amount of urine formed, amount of urine released from the body reduces means amount of waste material is getting collected in our body increases. Correct? Why? It is not released out, right? So it is getting collected. Getting collected means waste toxic components get collected in our body, that becomes allergy in our body. That may be leading towards some other diseases, disorders as well. Okay, so this goes up with nephritis condition. What are we supposed to do? Sometimes due to damages that occur in glomerulus, filtering process is also affected, and as a result, red blood cells can be passed into glomerular filter. If the glomerular area is getting damaged, what is getting filtered may contain red blood cells. So it becomes red in color. The urine passing would be red in color. And similarly, proteins also can be filtered. Why? Initially we told red blood cells and proteins strictly will not be present in glomerular filtering. But if the filtration process is damaged, then red blood cells and proteins will be there. So it's a disease condition, a problematic condition, right? Medicine advice should be taken immediately. Otherwise, what happens? Loss of these essential proteins, strokes may occur. So if proteins are continuously released from our body, that leads towards strokes, leads towards heart issues as well. All of them are connected. Organs are connected. Okay, one after the other, we'll be getting into problems. Okay, so some symptoms are given: blood in urine, fever, increased or decreased urine output, deviated from the normal. Mental status changes. Well, if you are diseased, mentally you are blocked, right? And nausea, vomiting, rash, all these things happen as symptoms. You see, symptoms are very common symptoms, but the reason, root cause is different. And then the next one is calculate. This is what mainly spoken about. Calculate in that. What do you mean by stones in that? What is the stone in that? What is the stone in the that is some say pumpkin also. Pumpkin stones that. What is the stone? James? James? Darren? Right. Okay. This is also because of that. Different wrong diet systems. Or not sufficiently drinking water, alcohol, smoking, some medicines. Also goes to formation of some small crystals called calcium oxalate stones. What oxalate? Calcium oxalate stones. So calcium oxalate stones form in between the kidney areas like here. Okay. Or it may be blocking over there. Can you see? Now what happens? These pathways are blocked by like a stone there. Now what happens? The flow of urine will be blocked. Okay, flow of urine will be blocked. So urine filtration, urine formation, and the flow of urine will be blocked. Pressure increases here. It gives a pain. Right? It gives a pain. And then it passes over. It is blocking over there. So pressure increases. It may be damaging. What are we supposed to do? We have to remove it. Initially, the medicine should be given. The medicines are given in order to dissolve the stones and to clean it out. If it doesn't work, then you have to go for lithotripsy like laser ray treatment. Laser ray treatments are also there. Ultrasonic treatments are also there. Ultrasonic treatments are termed as lithotripsy. So ultrasonic or ultrasound waves at high frequencies are sent towards the targeted areas. Because of a high frequency, high energy it carries, the stone will be blasted. Okay, the stone, not the bladder. Okay, stone will be blasted. When the stone is the eyes are going up, right? So the stones are blasted. When the stones are blasted, slowly broken into small pieces, and then collectively it is taken off. Right? So laser rays are given in that way as well. If it doesn't work out, nothing works out, then you have to go for minor surgeries. But the person who has got this problem and solved it out still have the risk of forming it again. So we have to go up with the consulting and medication. Plus, drinking sufficient water is very much important. Avoid alcohol smoking. Okay. Avoid some food which is not good. All these things we have to concern. So these things we can't ignore. If we feel the pain regularly, if there is a pain during urination, okay, definitely we have to consult. Why? If there is a small stone form, maybe growing bigger. Initially milligrams may be converting into grams. Why? Getting collected like a large stone. Okay. So it's not something small which is small and which cannot be seen by our naked. Not like that. We can see. Sometimes very large stones will be present. Okay. Will be getting collected. So we have to make sure that proper treatments we have to take if we diagnose any of these problems. So these are all about the renal diseases, the kidney diseases. What are they? Renal failure, nephritis, and calculated blood. Clear the points? Any questions? Any questions? No. So make sure you drink sufficient water. Avoid so-called energy drinks. It may definitely affect. Energy drinks in the sense no energy is there, just water. Hydrated with something else, some chemicals are being there. Okay. Maybe directly affecting you. Do you think that those people, those who are selling, they really drink that? They won't. They won't. Okay. They are not drinking that. It is also not good. It is also not good in the sense. Anyhow, it contains carbon dioxide. Carbon dioxide content. More carbon dioxide is present. Right? So you are giving carbon dioxide to your body. That's not good. But still, some people used to drink, including myself. Okay. So I have been addicted to that. I have to say that otherwise when I am drinking that you will be coming and ask me, sir, you taught me that. That happened for me, that's why. Okay. So now somewhat I have reduced that. The thing is, because of the taste or because of the fizzy nature you are taking it, but totally it contains carbon dioxide. Totally contains carbon dioxide. This carbon dioxide entering into our body may be resulting in gastritis conditions also. Clear? Okay. So slowly you have to reduce. So you can go for a fruit juice. You can go for a fruit juice, fresh juice, directly from the fruits, or even the snack you can take. So much as possible, we have to avoid this unnecessary things. Okay, different names and energy things are coming. We have to avoid. Okay, so we move into the next part. That is blood circulatory system. Blood circulatory system. Okay, blood. What is the color of blood? Red or blue? Red. I show you blood is red color. Maroon color. Wow. White color? Yellow color. Yeah? Maroon color blood do we have pale to dark red. Pale to dark red. It differs. It differs. Person to person is different depending on the context, depending on the intensity of blood cells. Okay. So about this blood, we will speak how the blood circulatory process is happening. So with short notes, we are going to learn actually. Right? So you see, components of blood when we take, the blood mainly contains two. What are the two they contain? Blood mainly contains two. One is the blood cells. One is the blood cells and the other one is blood plasma. What is that? Blood plasma. Blood cells or corpuscles we say. What muscles? Corpuscles. Corpuscles. Okay. Blood cells or corpuscles. That is about 45% in blood. How much is the percentage? 45% in blood. What is the percentage? 45. And that is the solid red color cells. Solid red layer. Solid red layer. Solid means not like a solid stones and all. Okay. Relatively, they are solid in structure. Particles are closely packed. So solid red layer in blood is what we term as blood cells. Remaining 55%, it is in the liquid form. It is in the liquid form. This 55% in liquid form, we term it as the blood plasma. Blood plasma. So you see, liquid layer is blood plasma. In this liquid blood plasma, solid blood cells are suspended. Okay, suspended. So collectively, it is red color. Collectively, it is red color. So during certain experiments, during certain testings and all, during certain testings, okay, medical testings and all, we have to check blood cells and blood plasma separately. Okay. So you see, how do we do that? Look at this. Now, when we take the blood, there are some methods in the blood testing that we are using. Where the blood samples we take and we have to centrifuge. Centrifuging means it has to be rotated, not by hand. There are machines that we are using. At a high speed, it will be rotated for some time. After doing this centrifugation, what happens is blood will be separated in planes. Lower part would be red layer, upper part would be yellow layer. And it will be a solid structure, it should be a liquid structure. And it may be pale yellow to dark yellow depending on the components. Okay, again you shake it, totally become red in color. So, in some testings, we take only this missing of pipette, we take out the yellow layer, the plasma is tested. And cells are tested separately. Some commonly the blood is tested. Okay, so accordingly the blood should be drawn out. Right? So, related to blood, there are some more components that we have to take. What are the components? You see here, the blood we are dividing into two. What are the two? Blood corpuscles and blood plasma. Corpuscles of blood cells we divide into three. What are the three? Red blood cells, white blood cells, platelets. Red blood cells, white blood cells, platelets. Red blood cells are RBC, white blood cells, WBC, and the platelets. Actually, RBC and WBC are what the cells. Platelets are remnants. They are the remnants, the remainings of cells. So the cells are red blood cells and white blood cells. Okay. Have you counted how much red blood cells you got? Salman, how many red blood cells you have? Forgot to count. Go home and count it away. Right? How many red blood cells are there? Shall I count yours? No. No. Right? No, I have taken. Right. How much you got? Red blood cells. Okay. We get the count for 1 cubic millimeter. 1 cubic millimeter means when you take your ruler, 1 centimeter is there. That 1 centimeter is divided into 10 millimeters. How small it is. Okay. So, such a cube you take. I'm just drawing larger. Where 1 millimeter length, 1 millimeter width, and 1 millimeter height. Such an area, such a volume when you take, such a volume of blood within the blood, such a small volume, 1 cubic millimeter blood you take, this contains about 5 into 10 to the power 6 RBCs. 5 million RBCs. This 1 cubic millimeter even very small. Within that 5 million RBCs averaged, it's there. Okay. So how much RBCs are there in our body then? A large amount. A large amount. All of them are doing a work. Did you count asking? Yeah. I know. That's right. So these are counted using machineries. We have methods to count. Estimate. These are estimated counts. Okay. Taking several samples, we estimate the count and totally we are collecting. Right. So anyhow, you see, and that is also counted because we know the structures, right? Red blood cell does have a structure. That structures are what we count. And not by your naked eye, you can't see that. Under microscopes. Under microscopes, you do that. Under using the equipment. So you see, RBCs when you are taking, 5 million RBCs are there. Gender-wise, it is different. A small difference is there. And WBC you take, it's about 4,000 to 10,000 or else 11,000 WBCs there. And the platelets you take, it's about 150,000 to 400,000. 150,000 to 400,000 platelets are there, all designed boom. 1 cubic millimeter of blood. 1 cubic millimeter of blood. You understand? So in 1 cubic millimeter of blood, this is the amount, average amount of cells present. You understand that? Right. Now if you have a doubt, go home and count. Samim? Okay? Right. Make a video. Right. So is it red blood cells and white blood cells? These are the cells. These are the cells. I'm going to compare them. At once, I'm going to speak about all, right? Red blood cells you take, they are red in color. They are red in color. Then white blood cells are transparent. Okay, they are not white in color, they are transparent. Okay. We can't say transparent cells, right? We are using the word white. Even for light, we say white light. It's transparent. Now, some comparison. Red blood cells, red in color. White blood cells, transparent. First one. Second, red blood cells, they do have a biconcave shape. Biconcave means both the sides are concave, like a button. Both sides are in. Okay, both sides are in. Biconcave disc-like cells are what? These red blood cells. WBC you take, white blood cells are not biconcave. Not biconcave. That's the second one. Red blood cells are biconcave. WBC white blood cells are not biconcave. Third one. Red blood cells are small in size compared to white blood cells. White blood cells are relatively large. And that is why this amount is. Right? These are smaller, so a lot of particles can be added. Smaller in size, but greater in number. 5 million RBCs are present in 1 cubic millimeter, whereas only 4,000 to 11,000 WBCs are there in 1 cubic millimeter. So, amount is greater in RBC, less in WBC. And how much it is? RBC to WBC. Count when you take, it is about 600 to 1. For 600 RBCs, only 1 WBC is present. Okay, as an average ratio, right? 600 to 1 is the ratio. WBC to RBC, 1 to 600. Both the word you have to take, both the sides you have to take, right? So that's the average. And WBC you take, WBC got nucleus. WBC has nucleus, right? So there is a nucleus within WBC, but RBC has no nucleus. RBC has no nucleus. So what is the advantage of? Now these are the structural differences I spoke about. Okay, what are the structural differences? Tell me. Color, RBC red, WBC transparent. Size, RBC smaller, WBC relatively larger. Number, RBC is greater than WBC. Shape, RBC is biconcave, WBC is not biconcave. Okay, what else? Nucleus, RBC has no nucleus, WBC has nucleus. Right. Functionality. RBC is there to transmit oxygen, transfer oxygen towards the organs, towards the cells. How is it happening? Within this RBC, we have HB. What is HB? Hemoglobin. What globin? Hemoglobin. Within this RBC, we have hemoglobin. This hemoglobin is the person to carry oxygen. Hemoglobin is the person to carry oxygen. Okay. How many oxygen can carry? 4 oxygen molecules it can carry. I spoke about this earlier also. Right? Hemoglobin molecule. One hemoglobin molecule can carry 4 oxygen molecules. 4 oxygen molecules. Where is it carried? Towards the bodies. Towards the body cells. To supply oxygen. Why? At the body organs, living tissues only, cellular respiration must be happening. Presence of oxygen producing energy, right? So you can see here 1 HB molecule carries in 2 ways. I can take either 4 oxygen molecules O2 or else 8 oxygen atoms, that is 4. Correct? Single atoms when you take 2, 4, 6, 8. 8 atoms. As molecules you take, 4 oxygen molecules can be carried. Okay? So this is how oxygen is carried. To do so, the nucleus is not present. If there is a nucleus, this can't be done. Why? This is only one HB molecule, right? Lot of HB molecules may be there. So if you have a nucleus, if the, let's say if a vehicle, if the bus is loaded with goods, then the space given for passengers would be less, right? So if there are no goods, they are getting the maximum space. That is ideal. So if there is a nucleus, maximum oxygen cannot be transmitted. So since it doesn't have nucleus, so this gives more surface area, more space for oxygen to transfer. So that is the advantage of not having nucleus in RBC. WBC has nucleus. For that, they do have an advantage. So what is WBC doing? WBC protects our body from microorganisms, strange organisms. Okay, they kill them, they come closer towards the microorganism, they kill them, destroy them by phagocytosis. Phagocytosis. Or else they produce antibodies. Antibodies would be moving towards the blood, targeting them, and they kill. Like the missiles moving towards. Okay. So they go towards the strange organisms and they kill them. By phagocytosis and by producing antibodies, WBC protects our body. Protects our body. WBCs are produced in WBC, what you call the white bone marrow. RBC is produced in red bone marrow. Red bone marrow. So these are the comparison between RBC and WBC. You understand? Is that clear? So RBC, WBC comparison is what we made just. Okay. So shall I take a small note? Go to writing book, please. Go to writing book. Take the topic blood circulatory system. Okay. Take this note down. Take them both separately. Okay. Divide them as to show separated. Both the points, please write it down. Hurry up. Speak up. Allah. So that is how I told you earlier. Red layer and yellow layer is getting separated. Okay. Red color and yellow color layers are separated by that, and you can see here. So clearly, the red color cells are significantly distinct. You can separately observe them from other cells, by their structure. Right. Write them down quickly. Done. So we got the next one. A 2 minutes break. 5 minutes. Just a small break. Okay. Drink some water and come go. No need of break. No need. Yes. Don't go out, okay? Not going out. Friends. You didn't come? Why is that?
No, I have to know about it. I see.
No, she came. No, she came on Thursday. Yeah, she might be coming away. Playing.
Sorry, ma'am. Maybe grade 11 to mark करूँगा. कहाँ? Excel yes.
Well, take a break at once. I give no more breaks at 2:30. Finish up the break and we continue until 3:30. So if you want to play, finish up the prayers also. Right? Okay. So this is what we spoke about blood. So blood cells we discussed, and the next one is about the blood plasma. Blood plasma we take mainly it contains water, and along with water it contains soluble things. Okay, water soluble things and water insoluble things. Water soluble things and water insoluble things. Right? Water soluble things means whatever the things can be dissolved in water, being soluble in water, that will be transmitted. Non-soluble things, it won't be soluble in water, still collected within it will be transmitted. Okay, so the blood plasma we take. Mainly the blood plasma contains water and along with that proteins like fibrinogen, globulin, albumin and respiratory gases, oxygen, carbon dioxide, excretory substances, digestive end products, hormones, enzymes, minerals, ions, vitamins, whatever is added to body will be taken to the blood. Along the blood it will be transmitting. So simply blood plasma supplies offers the process of transportation. All the materials are transmitted towards the targeted sites by blood plasma. Being a liquid, it facilitates the transmitting service. Okay. So, white blood cells. When we come for the white blood cells, furthermore, we divide these white blood cells into two. What are the two? Granulocytes and non-granulocytes, or agranulocytes we see, right? Granulocytes and agranulocytes. Granulocytes means they got granules. Small tiny structures are there. Agranulocytes or non-granulocytes with no granules. Have a look on the board. Now the granulocytes are divided into three fields. What are the three fields? Neutrophil, eosinophil, basophil. What are the three fields, Salman? Neutrophil, eosinophil, basophil. Two sites are there on the non-granulocytes. What are they? Lymphocytes and monocytes. Repeat the three words. What are the three here? Neutrophils, eosinophils, basophils. Once again, neutrophil, eosinophils, basophils. And they are monocytes, lymphocytes and monocytes. Okay. So how do we divide them? We divide them in this way. Now this is about the blood cells. Okay. You can see the white blood cells. 5 images are given here. 5 images are given. That is, when you come for neutrophil, it has the nucleus. Okay, it has the nucleus. The nucleus is almost divided into 3 segments. 3 particles it is divided into. And the granules are also present. It is a rough diagram, okay? Neutrophils. Eosinophil, when you take this nucleus, this is about the nucleus, okay? Rough diagrams to learn about the structure. Here, you can see this is divided into 2 segments, 2 complete segments. Basophils when you are taking, it is also divided into 2, but not completely divided. Can you see? Not completely divided. You can see there are 2, but partially divided, not completely divided like this. So this is basophil. It is basophils. So these are the 3 granulocytes. Among the granulocytes, highest percentage is neutrophil, up to 70%. 40 to 70 or else 50 to 70%. It is present in blood. Okay, and then eosinophil and basophil. And lymphocytes in a take, almost a larger portion is covered by nucleus with no granules, that is lymphocytes. And the monocytes you take, partially it is covering by the nucleus. Partially, only a part is covered by the nucleus and no granules. Right? So lymphocytes, almost a large area is covered by nucleus, but monocytes partial. And both of them have no granules. So they are non-granulocytes. Among the non-granulocytes, highest percentage is lymphocytes, up to 40%. Up to 40%. The ranges are different. So you see, if the question asks you what is the highest among all the white blood cells, neutrophils. Among only granulocytes also, neutrophils. Among the non-granulocytes, it should be lymphocytes. It should be lymphocytes, not neutrophils. Is that clear? So this is a rough structure given for all five. Rough structure given for all five. So these structures are also given on YouTube along with their percentage. It is given over there, right? So about the red blood cells, we already discussed about. Okay, so all the points are there, and it is about 4 months lifespan. The red blood cells have got, and they are being produced in red bone marrow. And the function, it is a it contains containing a pigment called hemoglobin. This hemoglobin is what transferring oxygen, making oxyhemoglobin. We discussed about that, right? And then leukocytes for red blood cells. We are giving another name. What is the other name? Erythrocytes. We see. Okay, erythrocytes. We see. White blood cells. We are giving another name. That is leukocytes. Platelets. We are giving another name. That is thrombocytes. Thrombocytes. So can you please take that page below? Before that, yeah. So I think we didn't mark that structure of blood, right? Shall I take it out quickly? Quickly mark it down. I'll make it fast. Done. Hurry up, please. Right. Go to the topic. Blood cells. Write the three names. Red blood cells, white blood cells, platelets. Red blood cells, white blood cells, platelets. In front of red blood cells, okay, front of red blood cells, write the erythrocytes. Front of white blood cells, leukocytes. Leukocytes. And then platelets, thrombocytes. 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 Okay. Fine. So you see here, white blood cells you are taking. What is the function of WBC? Function of WBC? It is to protect the body from microorganisms. They kill the microorganisms by phagocytosis and producing antibodies. Okay. Types of white blood cells we learn now: granulocytes, non-granulocytes, granules, neutrophil, eosinophil, basophil. Three fields are there. A granules, two sites are there: lymphocytes and monocytes. Lymphocytes and monocytes. Agranulocytes means non-granulocytes. A granules means non-granules. Non-granules. Okay. So this is the percentage. You can see neutrophil 50 to 70%, eosinophils 1 to 4%. Percentage may be changing depending on the person's blood component, the blood content. Okay. Basophil 0 to 1. So even if it is not there, it is not a problem. Lymphocytes and monocytes 20 to 40% lymphocytes, and monocytes up to 8%, 2 to 8%. Platelets. Platelets are there without nuclei, and they are the fragments of cells. 400,000, 150,000 to 400,000 platelets, maybe they are in 1 cubic millimeter, and they are also formed in marrow bone. Okay. And what is the function of these platelets? Platelets are functional for the blood clotting process. 5 to 7 days lifespan is there during they call any wound, any wounds. So let's say there's a wounded area. There's a wounded area on your leg, on your hand. So there's a wounded area. So this is like an open tap. When you keep the tap open, the water flows out. Okay, water flows out. So let's say it's damaged, you're going to cover up, wrap it out with a sort of material or something. Still it won't stop, right? Temporary you can block it. You have to replace. Or you should have to totally seal it. So same thing, like when you get into a wound or an injury or else an injury, what happens? There should be a regular mechanism to stop it. You can't just cover it with the bandages, and the bandages are giving a temporary work on. What is the biological mechanism here? Platelets come over there. and the platelets burst and release out a component called thromboplastin. What plastin? Thromboplastin. Thromboplastin. And along with this thromboplastin, one after the other, there are 4 factors totally being used. What are they? Prothrombin, fibrinogen, calcium 2 plus ions. What are they? Thromboplastin. Repeat the words, everyone. Thromboplastin, prothrombin, fibrinogen, calcium 2 plus ions. Once again. Thromboplastin, prothrombin, fibrinogen, calcium 2 plus ions. So these are the factors needed for whom? Blood clotting. Blood clotting. These are the factors needed for blood clotting. Okay. So you see, platelets are needed. And how it is connected? Platelets are containing thromboplastin. Okay. Now what happens? They come closer. Slowly the fiber-like structures will be forming up, and the blood cells are blocked. They come together, they make a larger clot there, they stop bleeding out, they dry, cover up. Slowly yellow color could be covered and the skin dries. So this is happening as the blood clotting. Blood clotting. So you see what we do? Sometimes this fiber also we are removing. When the wound is getting recovered, okay, it's dried up, still you are looking at that slowly removing the fiber. That happens. What happens then? Again, it bleeds. Why? You are removing not the stitch. It's something you have to stitch it. You are removing it. So again, bleeding occurs. Again, bleeding may occur. So according to say, this is a natural mechanism happening in everyone. Everyone. So this is blood clotting. For blood clotting, platelets are important. For blood clotting, platelets are important. So can you please take a note? Factors needed for blood clotting. Factors needed for blood clotting. Do you have space closer to platelets? There we can write. On your tube, closer to that platelets, there's a small space to the right side. Factors needed for blood clotting. Very good. Okay. So we come for blood plasma. Blood plasma, it is the yellow layer, almost 55% liquid yellow layer it is. Okay. All the substances added to it, dissolved in it, would be transmitted from one place to the other. Right? Some examples, what are the examples? Respiratory gases are taken towards the respiratory organs, excretory substances are taken towards the excretory organs. Okay. And for all the biochemical reaction, the space, the room is given by blood plasma. Okay. And the hormones, proteins, enzymes, antigens, antibodies, all of them are taken towards the targeted place by blood plasma. So simply blood plasma is our transport service. It is what? Providing transport from one point to the other wherever they are needed. Okay, forward and backward, all that is done by blood plasma, right? So that's all about the blood components. So you see blood plasma mainly contains water and nutrition are there. Second most component is proteins. What are the types of proteins present? Albumin, globulin, fibrinogen. You have to remember them. This comes in MCQs. Albumin, globulin, fibrinogen. Right? Fibrinogen. And what are the nutritions? Monosaccharides, amino acids. So all the digestive products, you learn the digestive system, right? Monosaccharides, glucose, fructose, galactose, amino acids, vitamins, minerals. Okay. So without digestion, they are. And vitamin. So these are they are present in they are the digestive products. And then ions, sodium plus, potassium plus, calcium plus, sodium plus, chloride minus. So all these things are present within the blood as ions. And vitamins are there, minerals are there, antigens, antibodies, hormones, enzymes, gases, respiratory gases, and nitrogenous byproducts, urea, uric acid. So all these things are there to the target places that is carried out by blood. Wherever the exchange is needed, tiny network capillaries, okay, network of capillaries will be formed up around the organ via the blood capillaries, it will be sent out. Because capillary networks are very tiny and the walls are also very thin. So it's easy to transfer the substances. Okay, fine. Any questions up to this? Any questions? Albumin? Yeah, albumin is a type of protein present in the eggs as well. Once you eat, once you consume, that will be added to the blood. So this is also one of the main component as a protein. Fine. What is this? It is your heart. It is your heart. How many hearts are there? I mean, two of them. Two of hearts. Good. Good. How that? Where is it? Between the lungs, slightly heavier to the left side. Between the lungs, slightly heavier to the slightly lower to the left side, we have the heart. And it's not a larger organ, smaller than the lungs. Okay, just like our. Okay, so this is an average size of the heart. Okay, average size of the heart. And this does the work to remain as alive. Okay, remain as alive because what is this heart? No, different symbols you are giving heart. No? Different symbols. No, different symbols you are giving. This way. Okay. Fine. Now you see, all the symbols are just symbols. Just symbols, icons, iconic symbols, referring to different so-called emotional stories. Okay. Now, heart is nothing. Heart is nothing. Just a blood pump. Heart is nothing. Just a blood pump. Okay. Blood pumping is the biggest tool. But I told you, right? We keep on finding different things. Recently, it was found that heart is connected to emotions. Recently it is found. But that means that is why you say those things are blind we see. Correct? Right. Blind we see. Why blind? You don't know what the hell it is. Okay, but still you feel like it's butterflies flying off. Okay, different stories happen. So you see, it is just a blood pump. What is just a blood pump? Recently it is found that emotions are connected over there because of the waves, because of the signals and all. Okay. So you see, anyhow, this heart when we take, heart connected with the blood vessels carries out the blood circulation. Heart pumps blood towards all the organs. Okay. So you don't store emotions over there. Recent studies show that, but we have to, explore that, how much it is happening with the connection. Right? Anyhow, the heart and mind are connected. Right? So all what you remember, not in heart, okay? It is in mind. It is in mind. So we say, different blind stories are saying, I'm giving the space in my heart, we say. Is it a storeroom or something? It stores blood, nothing else. It stores blood, nothing else, right? So all those stories are coming because of the age issue. Bottom of the heart. Bottom of the heart actually are having the ventricles here. Ventricles. That is the place where the blood is pumped out. Okay. You have oxygenated and deoxygenated blood only. No one else is there. Now some people are there and 4 chambers are there. 4 chambers are there for 4 people. That is also there. Right? So 4 chambers are there for 4 blood components. Okay. So oxygenated blood is there in the left side. Deoxygenated blood is there in the right side. Okay, right side deoxygenated blood. Left side oxygenated blood is connected. And these are the chambers. These are the rooms collectively made to make the regulation or to regulate the blood flow properly. Okay. So blood is not flowing there, nothing else is flowing over there, right? So it is connected with the blood vessels. Connected with the blood vessels. So blood vessels are working in order to transport this blood. So first we must know the parts of this heart. Upper chambers are called atrium and the lower chambers are called ventricles. Upper chambers are called the atrium, lower chambers are called the ventricles. So this side is our right side. So lateral inversion. Laterally inverted, I am taking the diagonal in my angle, in my direction. This is the right side, this is the left side. Okay. So right side upper chamber we name it as the right atrium. But atrium, right atrium. Left side upper chamber we name it as left atrium. Right side lower chamber, we name it as the right ventricle. Left side lower chamber, we name it as the left ventricle. So accordingly, two atriums and two ventricles are there. Right? So now, you see here, these are connected with blood vessels. These are connected with blood vessels. What are the blood vessels? Right atrium is connected to two blue color ones. Right? And red color ones are also there. What is the story? Now look at this. When you come for heart, I told you heart is the blood complex. Heart takes blood towards the organs. It may be the upper organs or lower organs, above the heart, below the heart. Right? What type of blood it takes? Basically, it takes oxygenated blood. What is the blood? Oxygenated blood. Heart pumps oxygenated blood. Only one place it is changing. When we learn, you can understand. So this oxygenated blood is mainly taken by arteries. What is that? Arteries. Arteries are taking blood away from heart to other organs. So remember, heart pumps blood into arteries. Arteries take the blood away from heart to other organs. Right? So oxygenated blood means oxygen more, carbon dioxide less. They say no carbon dioxide also. There is a small amount of carbon dioxide. That is how the diffusion happens. Diffusion means high concentration, low concentration, transmitted. So now what happens? This organ, the base of organ, that is the base where the cellular respiration happens. We learned under respiratory system. This supplies oxygen. So supplying oxygen, cellular respiration happens. At the presence of oxygen, glucose breaks down into carbon dioxide, water, releasing energy. Energy will be used up. The carbon dioxide is there, will be given along with water waste. So it takes in oxygen, gives out carbon dioxide. So this carbon dioxide is once again taken back towards heart. And who does this? This is done by veins. So basically, deoxygenated blood. Deoxygenated blood means oxygenless, carbon dioxide. Only one place this should be exempted. That is between the heart and the lung. Between the heart and the lung. So let me take this way now. You take the heart. Heart has four chambers. Okay. Heart has four chambers. What? Whatever. Big heart. Left side, right atrium, left atrium, right ventricle, left ventricle. Okay. These are the upper organs. Upper organs. And lung. How many lungs you got? One. But about the other lung? Two lungs are. And the lower organs are there. Lower organs. Okay. Look at this. Look at this. Now what happens is, look at this. I'm explaining the theory. Now the organs is the place where you need oxygen increasing carbon dioxide. So I'm starting from the increasing carbon dioxide. Okay. From all your organs throughout the body, where are the living cells? Living cells are there. Organs which containing cells, right? Cells. Okay. So let me replace this word. For the fundamental part, cells. For the living tissues, the cells is supply. Cells produce energy and releases carbon dioxide. This is deoxygenated blood. So this deoxygenated blood is carried from the lower organs toward the right way. Toward the right way. And who does that? This is done by inferior vena cava. What cava? Inferior vena cava. Or else vena cava. Not cava. Not cava. Okay, not cava. Vena cava, vena cava. So inferior vena cava carries deoxygenated blood. It is providing O. It is giving carbon dioxide. Deoxygenated blood towards the right way. From the lower, all the lower organs. Upper organs are there in the head, shoulders, arms. They are the lower. They are the deoxygenated blood is carried out by another vena cava. Who is that? Superior. Yes. superior venous cava. Right. Cava. Superior venous cava. So superior vena cava and inferior vena cava, both of them are collected. Deoxygenated blood where? In the right atrium. In the right atrium. Okay. They are opening. Now right atrium fills up with deoxygenated blood. Deoxygenated blood should be passing down. Right atrium squeeze. It will be squeezing. Right. When it squeezes, blood transfers down. To do so, there is a valve here. There's a valve. And that the valve would be opening only in one direction. Opposing one. Okay? Only in one direction would be opening. Pinball games opens in only one. Opposite direction it won't. It closes. So this valve would be opening only in one direction, not back side, not the opposite side, because to prevent the backflow of blood, so that the blood won't come up. Right? So this valve we name this valve as, it is the right side, right? We name it as tricuspid valve. What is the valve? Tricuspid valve. Tricuspid valve. Between the right atrium, right ventricle, you got tricuspid valve. Tricuspid valve. Okay. So what is the blood given here is deoxygenated blood. So this deoxygenated blood is what transferred down. Okay. Deoxygenated blood is what transferred down. So remember, right side tricuspid and the right side contains deoxygenated blood. Right atrium squeezes. And now the right ventricle squeezes. Now this blood would be taken by whom? An artery. There are two arteries here. Starting from a valve, it goes out. And we name these arteries as pulmonary. Pulmonary. Okay? Pulmonary arteries. Right? Pulmonary arteries. Some they read it as pulmonary arteries also. It's pulmonary. Indian English and all when you are taking, basically they make it like that. Pulmonary. So it's pulmonary arteries. So these pulmonary arteries, you see, this is taking the blood away from the right ventricle towards the lung. And what type of blood it is? Deoxygenated blood. So see, all what is connected to the right side contains deoxygenated blood. Okay. Now there is a valve here. This valve we name as semilona valve. What is the valve here? Semilona valve. Semilona valve. Now the blood is sent to the lungs. Blood is sent to the lungs. Now lung is the place where the air purification happens, right? This gives carbon dioxide. It is giving carbon dioxide. And this is the carbon dioxide we are exhaling. This is the carbon dioxide we are exhaling. Correct? Now we inhale oxygen, right? Now deoxygenated blood contains carbon dioxide, right? Carbon dioxide, right? More carbon dioxide. So this carbon dioxide will be given to the lungs. That is the carbon dioxide we are exhaling. We already inhale oxygen, right? Now that oxygen is there in the lungs. Lungs contain oxygen. That oxygen will be given for pulmonary veins. What veins? Pulmonary veins. So the pulmonary veins are taking the blood. Pulmonary veins are taking that blood towards whom? Left atrium. Left atrium. So that is pulmonary veins. So the pulmonary veins are taking oxygen. Oxygen is given here towards the left atrium. So left atrium is filling up with red color. We indicate oxygenated blood. Oxygenated blood. So left atrium is filled up with oxygenated blood. And how many pulmonary veins are there? There are 4 pulmonary veins. 2 left, 2 right. Okay, 2 left and 2 right. Pulmonary arteries 2, left and right 2 pulmonary arteries. I'm not showing all 4 here, just one I took here. But remember there are 4 pulmonary veins. Now the pulmonary veins are giving oxygenated blood here. Now this oxygenated blood should be pumped down. It transfers down along with another valve here. What is the valve here? This is the bicuspid valve. What is the valve here? It is called bicuspid. So there are 2 cuspid valves. Bicuspid valve is between the left atrium and left ventricle. Tricuspid, right atrium to right ventricle, tricuspid valve is there. So now this blood transfers down. Blood transfers down. And that is oxygenated blood. Oxygenated blood. Now left atrium squeezes, blood goes down, left ventricle fills. Left ventricle also then squeezes. Okay? It contracts actually. Contracting is. When it is contracted, it is squeezing. What happens? Now this blood across another valve will be sent out. And that is the large artery. Why artery? Away from the heart. And this artery takes the blood towards all the other organs. All the other organs. It is not directly providing that blood, okay? It is dividing into branches. Something like the main road when we are taking. There are substreets also, right? There will be substreets also. These are larger. And how do you name these? We name it as aorta or iota. Another word we are giving systemic artery. What artery? Systemic, not systematic, systemic artery. Systemic artery. So this takes away what blood? Oxygenated blood. So oxygenated blood is taken away from left ventricle via the aorta into all other body organs, and now it is providing whom? Oxygen. It is providing oxygen, correct? It takes carbon dioxide out and now it is supplying oxygen. So giving oxygen, cellular respiration will be happening over there. So accordingly, you see, here the valve is also called semilunar valve. Here the valve is also called semilunar. So you see, you got two semilunar valves. One is at the starting point of pulmonary arteries, the other one is at the starting point of aorta. Aorta. And we are giving special names for that. At the starting point of pulmonary vein, we name it pulmonary artery, we name it as pulmonary semilunar valve. Pulmonary semilunar valve. And here it is aortic semilunar valve or systemic semilunar valve. So this is the structure of heart in short. These diagrams also would be coming in the question. Okay. So you must know the flow of blood, the direction of blood. So you see here, when the blood flows once throughout the body means from the lower organs, it comes towards the heart. And it goes out from left ventricle towards all the organs. So once when the blood is circulating throughout the body, it enters twice the heart. What is the point? Once it enters the right atrium, leaves the right ventricle, again it enters the left atrium and leaves the left ventricle. So you see, when blood circulates once throughout the body, it enters the heart 2 times. It enters the heart twice. So this is called double blood circulation. What blood circulation? Double blood circulation. So when the blood flows once throughout the body, twice it enters the heart. This is called double blood circulation. Double blood circulation. So now the blood exchange between the heart and lungs. Right ventricle pumps the blood. Okay, right ventricle pumps the blood towards the lungs. That is carrying out by pulmonary artery. So that the blood is purified and oxygenated blood is taken from lung to left atrium. Pulmonary veins. Pulmonary veins. This circulation between the heart and the lungs, we name it as pulmonary circulation. What circulation? Pulmonary circulation. Right ventricle pumping blood goes to lungs via the pulmonary artery. Purification happens, oxygenated blood comes via the pulmonary veins towards the left atrium. This is pulmonary circulation. Right ventricle to left atrium. And now the left ventricle transfers blood, right? Pumps blood, right? And that is oxygenated blood, right? Left ventricle pumping oxygenated blood goes throughout the body and providing oxygen to the targeted cells, taking off carbon dioxide and comes back via the vena cava to the right atrium. So this is carrying deoxygenated blood. This circulation is called systemic circulation. What circulation? Systemic circulation. Now pulmonary plus systemic both collectively when we take, that also we name it as double blood circulation. Double blood circulation. So accordingly, you see, for the pulmonary circulation, who is the blood pump? Right ventricle. For the pulmonary circulation, who is pumping out blood? Right. Pulmonary means towards the lung. Right ventricle. Who is the blood pump for the aortic circulation or as the systemic circulation? Left ventricle. So left ventricle pumps out oxygenated blood. Right ventricle pumps out deoxygenated blood. Deoxygenated blood. Is that clear? Totally clear about that? So this is how the circulation happens, and I told you this theory that arteries carrying oxygenated, veins carrying deoxygenated changes only at one place. What is the one place? Can you see here? Right ventricle. From heart, blood goes out, should be arteries. In fact, it is arteries, pulmonary artery. Pulmonary artery. So this is PA, pulmonary artery. And this is pulmonary veins. Okay? Pulmonary arteries takes the blood. Artery should be oxygenated, right? But here the artery is deoxygenated. Why deoxygenated? Because right side is connected with deoxygenated blood. You understand that? Right side is connected with deoxygenated blood. So this is carrying this is carrying deoxygenated blood. This is carrying deoxygenated blood. Correct? Carrying deoxygenated blood. And pulmonary veins must carry deoxygenated. But here, pulmonary veins carry oxygenated blood. Why? It comes from the heart. It comes from the heart. So it is what providing oxygenated blood towards the heart. Correct? So it is what carrying oxygenated blood towards the heart. You understand that? So that is the only point where it is changing. All other places, arteries carry oxygenated, veins carry deoxygenated. Now these things at once you can't remember. You have to refer. You have to refer to it in your own. You have to speak to yourself and learn. Got it? So accordingly, is to make it easier, this blue color and red color I'm showing you. So blue color indicates that it is deoxygenated blood. Okay, blue color indicates that it is deoxygenated blood. Red color indicates that it is oxygenated blood. Oxygenated blood. Is that clear? So further, if I want to take all these things are deoxygenated. So I told you, right side of your body is connected with O, deoxygenated. Right side of the body is connected with O, deoxygenated. Left side is connected with oxygenated. Left side is connected with oxygenated. So accordingly, aorta is what taking blood towards all the body organs. And also I told you, aorta is not directly supplying blood for all. It is having branches. It's having branches. Where the branches, it is dividing into the branches. It provides the blood for all the organs. For an example, for kidneys, renal artery. For intestines, intestinal artery. For the liver, hepatic artery. Likewise, arteries and veins are being separated. Yes. When you draw the diagram, aorta is up. Above the heart, aorta is up. But it is connected over there. Okay, it is connected over there here to give the pressure. So the pressure is very high. Left ventricle exerts a high pressure to pump blood because that the blood should be taken towards all the organs, right? So to take blood towards all the organs, high pressure is there. So higher pressure is exerted by the left ventricle. That is why the left ventricle walls are thick and elastic than the others. Because it has to exert a high pressure to withstand that pressure, it is having high thickness and high elasticity. Is that clear? So this is about blood circulation, the double blood circulation. So further we write double blood circulation is equal to whom it is equal? Whom it is equal? Double blood circulation is equal to pulmonary circulation. Okay. Double blood circulation is equal to pulmonary circulation plus systemic circulation. Systemic circulation. So we say when once it goes throughout the body, it enters the heart 2 times. It enters the heart 2 times. Clear the point? Clear? You have to refer. Okay, at once, as I told you, at once you can't remember because a lot of names are there, a lot of terms are there, you have to connect it. So some short methods are there for you to remember. That is, all what is connected to the right side contains the oxygen, right side of the heart. And all what is connected to the left side connected to the oxygenated blood. That is one point. That is one point. Okay. And if the heart takes blood away from it, should be an artery. If any vessels coming towards the heart, should be a vein. So these are the 2 points you have to remember. Clear? Clear? So take the diagram down. You have to draw it. Draw it. Take one complete page. Take one complete page. Draw it a bit larger. Okay. Otherwise, you will forget. These diagrams are there. Related diagrams are there on your note as well. But I want you to draw and learn. Otherwise, you will forget. You will find it. And better if you can use the red color, blue color pens if you have. Blue color, somebody do have, right? For red color, any other colors you use? Okay. Any light colors? Please go ahead. Take one complete page, draw. Taking one complete page, don't draw small, okay? Draw it covering up at least 70 to 80% of the page. Now drawing smaller, don't take the lines large, okay? All these things you will do. Properly draw it. Yeah. Yes, yes. Why not? Yeah, please. Quick write. We have to go to the next one also. What we learned, we have to fill up, otherwise you will forget. So you need 15 minutes for this. Draw it, man, quickly. Hmm? Write quickly. When is your school exams? Second term? Sixth chapter done? Wow. So I writing. So target the second term, okay? Please make sure you refer before the exams, okay? You can't be just writing answers. You have to refer completely all what we have done. Some in your schools you might have done even the other chapters, but we are going on an average speed, not as an express. Okay, we are targeting the O levels because anyhow the school exams are different, right? Some of them are having still the first term. It differs, and some schools are there suddenly they change. Suddenly they change the terms. Anyhow, next week Sundays we are planning up with some revision series for grade tens. Grade tens. It goes like 3 days actually. All 3 Sundays from next week onwards, I'm going to take, and there would be a combined seminar for science and BA studies on 20th. Combined, yeah. Combined seminar, 2-in-1 seminar on 20th. That is also targeting grade 10s where the grade 11s also can join. Okay. So taking some important points from fundamentals from both the chapters, both the lessons, both in BS and science, falls on 20th. 20th. And science would be done all 3 days. Also grade 10s and grade 9s would be also done. Grade 11s, we'll see, since we are already doing the paper classes and all. I think it's not necessary at the moment. If it is, we'll see. Chemistry. Now, chemistry, anyhow, now we started. I told you, this month I'm doing the grade 10, unit 7 and 10, both chemistry. If anyone needs to join, I ask you guys to join that class. Okay. So, fee, it's totally free of charge. Free of charge means only for the tunes you are paying. Okay. You can attend the classes, all 4 classes where you can learn the theories. Okay. 7th chapter already started. The basics of 7th chapter already started. Next week, you'll be finishing up the 7th chapter, inshallah. So at least try to join from next class if you really want to practice them. Anyhow, those chapters will be once again taken as a revision later. Grade 11, we'll see if we can have a seminar or whatever before the second term. Yes, left also. Both. Both you heard of it. What? Finished? Right. Are you done? Yes. Finished? Hurry, please. We have one more small part. You're right then. Just filling up. Filling up, filling up, filling up. Both the diagram you have to do. Both you have to do. Don't take it too much hard. It's not a hard diagram, okay? Not a hard diagram. Finish, right? Okay, let's fill up the tube. Filling up the tube. If you quickly write, we are quickly ending up. What are the chambers connected? Right. Because they are down below the heart. What are you? What are the chambers? What do you? Yeah. Left atrium, left ventricle. Right atrium, right ventricle. Left atrium, left ventricle. Right atrium, right ventricle. Still drawing? I need to raise the board. Shall I? Okay, Krishna. So what are the four chambers? Left atrium, left ventricle, right atrium, right ventricle. And then there are two valves between the atria and ventricles. What are they? Bicuspid valve between the left atrium and left ventricle. Second one, tricuspid valve between the right atrium and right ventricle. That's right. Second point, write that. First point we wrote the chambers. Second point about the cuspid valves. Quick write. Write a book. Tube. Fill it up. Go home and write. Right. Right now. Go home and fill it up. Bicuspid valve is in between. Salman, where is your bicuspid valve? Where is your bicuspid valve? In what? Write it down, please. Shamim, where's your right? I just asked you, where's your right? Don't know? Oh, so far you found your right side, no? Please write me. Completely write that. I'm giving you it on the screen, right? Bicuspid valve is in between the left atrium and left ventricle. Tricuspid valve is between the right atrium, right ventricle. There are two main arteries connected to the ventricles. What are they? Left atrium is connected with whom? Left ventricle is connected with whom? Aorta, systemic artery. Right ventricle is connected with pulmonary artery. Like that. Aorta starts from the left ventricle, pulmonary artery starts from the right ventricle. That's the third point. Aorta starts from left ventricle. Aorta starts from left ventricle. Pulmonary artery starts from right ventricle. That there are semilunar valves at the starting point of the main arteries. What are they? At the starting point of aorta, aortic semilunar valve. Starting point of pulmonary artery, pulmonary semilunar valve. These two. What happened? Not me. And you don't want to search about who the hell was that. Just otherwise, it is also a lesson for you to learn. If the main names were given, all these names you have to learn, right? Right, done. The next one. Main veins are connected to atria. What are the main veins? Superior vena cava is connected to from upper organs to the right atrium. Right atrium. From lower organs to the right atrium, inferior vena cava. Right. Properly orderly write them, okay? Write them in order. Don't mix the points. Done. Do memorize all, okay? You have to refer all those things and you have to remember the points, okay? The structure is a question, there's a guide as well as MCQs. These lesson are with my college. Fine. We're done for today. So circulation already I have discussed with. So next week we have to just continue writing, filling up the notes, and then we'll take the cardiac cycle, heartbeat, and all. Okay. Have a break. Half an hour. We'll be starting up with the paper. Four, 5, 4, 4. 34. One more minute, you come late, become a reaction. Ajmal done? All done writing? Islam. Slowly. Hmm? Give me a minute, please. Okay.